Hey Diggies, welcome back to BiharGeeks. So today we will solve a very interesting problem, that is maximum depth of binary tree, and this is a very classic recursion based problem which is asked in many FAANG interviews. So by the end of this video, you will going to understand the first the problem statement. Second will the approaches. I'm going to follow two approaches here. First is the recursive, where I'm use the concept of DFS, and second will be the iterative approach, where I'm using the concept of BFS. Okay, and where I'm going to tell you the step by step implementation how I'm going to do. Okay, so let's dive in and start the first with the problem statement. So the problem statement here says that we have given it a binary tree. Okay, and we need to find the maximum depth. Okay, the maximum depth basically is the number of nodes along the longest path from the root to the down to the deepest leaf of the node. Okay, here as you see, the depth is basically 3, because if you count it, 1 2 3, so the depth is shows here 3. And if we move to the another example, there is 1 null and 2, so the depth will be like this. There will be a root, this will be a root, and this will be left, and this will be the right. So one is will be here, this will be the empty side, and next side will be 2. So if we count 1 and 2, that's why the height of this is 2. Okay, basically the depth of that. So the approach I'm going to follow here first will be the recursive approach. Okay, where we will use the concept of DFS, that is depth first search. Okay, so there will be first a base case here. Base case will be that we will check that our node or the root is null or not. If it's null, so we will just directly return 0 from there, and otherwise we will recursively compute the left and right subtree. Okay, we will check the depth of that, and to find the depth we will use the formula like 1 plus, and where we will put a max, where we will calculate the left and right. Whatever will the max, we will just simply return it. And the complexity for this, for the time complexity for the recursive DFS approach will be O of n, because we are visiting each node once only. Okay, and the space complexity we talk about in the worst case will be O of n because of the recursive stack. Okay, so let's dive in. And as you see that that tree node is already created here, we just need to write the actual code here to find the maximum depth of the binary tree. Okay, so first we will have to put the base case here. So if root is equal to null, so we will just return what will we return? Simply 0. Okay, second have need a left depth or right depth. Depth equal to this function, we will call it iterative way, sorry, recursive way. So inside that we will pass root dot left, right, and second will be the right depth, and inside that we will pass root dot right, right, and we just simply need to return 1 plus math dot max. Okay, and inside this we have to pass both the left and the right depth. I just copy this and paste it here, and second will be right depth, and I'm just paste it here. Okay, so using this we will get the max depth from here. Let me run this. Fine, it's got accepted. Let me submit this. Okay, it's got accepted also. So the key point to be noted here, that we have used the recursion to traverse the tree, and we have calculated the depth by the bottom up approach. Fine, and the complexity we already talk about that, the O of n. Okay, And the space complexity is same, like O of n only, because of the stack we are doing the recursion thing. Okay. Second approach is the BFS. Okay, and we can call it as iterative BFS approach. So let's start with that. So here, what will we are going to do? We will use a queue here, and at each level we will count how many nodes are in the queue. Okay, and we will process all the nodes at the end, and then we'll move to the next level. And depth increases by approaching each level. Okay, level by level we are going to move. Fine. Okay, let's start with the logic. So the first line will be same in this case also. We will have to check the base case. If the root is already null, so we will just simply return 0. Okay, and next step will be we need a queue here. So, and it will be of type tree node, right? And we'll name it as queue equal to new linked list, right? After this, we have to add first the root here. Q dot, sorry, add, and inside that I have to add the root. Hmm. And we need the result that will be, we'll keep it inside a depth. And currently I'm putting 0 inside it. Okay. Now we need a while condition until it's not empty. Q dot is empty. Okay, and inside this we'll put the need a size here. Okay, and size will be the size of the queue. Q dot size, right? And we will increment the depth of depth basically in each level. So I'm just doing the increment of that, right? Which we have right now, we have declared that depth equal to 0, right? Now we need a loop, and I equal to 0, and I will be till less than the size. Okay, the size of the queue basically, and I plus plus, right? And inside that we need a tree node. Is a variable which we name it as current equal to, and inside that we'll put the pole, q dot pole, right? Now we have to check left and right, and we'll add inside a queue. So if current dot left is not equal to null, okay, and not equal to null, so in that case we just need to add it. Current dot add, sorry, current dot left, uh, left, right? I'm just copying it because we have to do it same thing for the right. Right, copy, and same I have to paste it here. Fine, this is done. Now after everything is done and we are just coming out of this loop, so we just need to return the depth. That will be our result. Fine, let me run this. Fine, it's got accepted. Let me submit this. Okay, it's got submitted also. So the time complexity for this case is also O of n, and the space complexity is also O of n, because we are storing the nodes in the queue. Okay. So which approach should you going to use in your case? First is the which I showed you, that I'm using the recursive approach when we basically want a clean and simple implementation. Okay, and second was our iterative approach, where we have used the queue and using the concept of BFS, where we are dealing with the wide tree and as it avoids the deep recursion. Fine. So that's it for the today challenge, and we have solved this maximum. One second. We have solved this maximum depth of binary tree using recursive and iterative approach both. We also have analyzed the time complexity in both cases, the time complexity of n only, and that's all for today. Thank you for watching. Bye bye.